Okay, let's talk about dependent and independent variables and how it relates to our linear equations. We definitely know by now the general form of our linear equation. Our y is equal to mx plus c. Okay, well, what you might not know is that the x is actually our independent variable. That's the variable that we can change. X can be any value that we want, any value that we choose. Okay, but what about this y? What are we going to call the y? Well, the y value is actually the dependent variable. So the value of y really depends on what the value of x turns out to be. What you choose for the value of x will make y change. Okay, so again, the value of y depends on the value of x. So when we're graphing these linear equations, the dependent and the independent have a specific axis that they are on. So the independent variable, the x variable, is always on the horizontal axis, and the dependent variable is always on the vertical axis. Okay, so what do I mean by that? Well, let's have a look at an example of one of these sort of questions that you need to know the difference between these dependent and independent variables. Okay, so here's our little story. To rent a bike, Max pays a flat rate plus an hourly rental fee. There's a graph I'll show you soon where it shows the amount of money he pays in dollars based on the number of hours that he uses the bike. So if you're asked to firstly identify what are the variables, well, it helps to be able to determine what are the actual individual variables that we're looking at here. So I need to move that over just a tiny amount. So what are the two variables? What are the two variables that we're dealing with here? Well, we know he's getting a bike, that he's going to be riding it for a while, and it's going to cost him some money. So there we go. We've got our variables. Our variables are time and money, or cost and time. So we need to be able to know which is the dependent and which is the independent. I think the easiest way to sometimes figure this out is to ask yourself which sentence makes more sense, right? Which one? Does the time depends on the cost make more sense than saying the cost depends on the time? I think the second one makes more sense. I think that the cost depends on the time. So that means that the amount of time that he's out on his bike for, time will be the independent variable. Okay, so time is the independent variable, which means it will be the x-axis, and cost will be the dependent variable, which means it will be the y-axis. Now, if I reveal the actual answer to this little graph that we have here, you will see that indeed we were correct. We've got time, which is, as we said, the independent or the x variable, and we have the cost, which is the y variable. And we can see and read this graph. If he was out for 6 hours, well, it would cost him $20. Okay, so it's really important to be able to determine which is the independent, which is the dependent, being able to make sure that we get that right. Let's look at one more example before we move on to something else. Okay, so Jenna is working in a retail shop. She's making $10 an hour plus $3 for every item that she sells. We got a bunch of different questions here. How much does she make in an hour if she sells 5 items during that hour? How many items would she need to sell in an hour to make $43 during that 1 hour? Okay, so, well, this one's a little bit trickier. What are the variables here? Well, we've got money. She's making money per hour, so there's time, and it's also about each item that she sells. So really there's 3 different variables, aren't there? Time, money earned, item sold. Well, it might feel like that, but that's not actually the truth. If you have a look, you'll see that she makes $10 per hour, so that's only 1 hour, and all the questions say that hour or that hour. So we really don't have to worry so much about time as our variable here. Okay, so if we're not worrying about time, it's really about the money that she earns and the items that she sold. Okay, so again, we have to ask ourselves a similar question in two different ways to figure out which is the independent. So which one is the independent variable here? Does the money earned depend on the items sold, or does the items sold depends on how much money she earns? Well, it's the first one, right? The amount of money that you make depends on how many items you sell. So if that's the case, money earned is the dependent and the number of items that you sell is the independent. Okay, so we can write that down. Items sold is the independent, money earned is the dependent. I just said that. Very good, so we've determined what our dependent and our independent variables are. Okay, now this hasn't really helped us solve anything just yet, but we're nearly there to the solving part. I'm going to move this all down. Now I've rewritten the question so that you can see again. Okay, so we figured out that now once again we need to remember that the items sold is the independent. So that means that the items sold would be the x-axis. That would be the horizontal, and the money earned will be the vertical. Okay, very good. All right, so back to the question. She's making $10 per hour plus $3 for each item that she sells. First question then says, how much will she make in an hour if she sells 5 items during that hour? Okay, well, let's look at a simpler version. How much does she make if she sells 0 items? Okay, so let's think about that. She works for an hour and she sells 0. How much will she make? Well, the story up the top up here says that if she's making $10 per hour. So if she doesn't sell anything else, she'll make $10. Okay, reasonable. What about if she sells 1 item? Well, she'll make $10 an hour plus $3 for each item that she sells, plus that. So she will make $13. That seems all right. And if she sells 2 items, well, she'll make the $10 plus 3, so 16. Righto. Now we've got some points, an x value and a y value. Now that we have points, we can actually work out what the linear equation is. All right, let's do that. You remember last video, what we did? First thing we need to do is determine what our m is. There it is, I worked it out. y2 take y1 over x2 take x1. I used the 13 and the 10 and the 1 and the 0, and I worked out that my x values, the m value, sorry, not x, the m value is 3. Okay, the only other thing I need is my y-intercept. Do I have it? Well, actually I do. When x is 0, y is 10. Oh gosh. So when x is 0, y is 10. So I know the whole thing. I know that y is equal to 3x plus 10. That's my linear equation for my question that I'm working on here. So I can now work it out. What will she make when she sells 5 items? Well, when x is 5, well, y will be equal to 3 times 5 plus 10, 25. She would earn $25 for that time. Okay, well, what about the next one? It says, how many items would she need to sell in an hour to make $43? Right, $43. That's a fair bit of money. So what would she need to sell to get that? Well, let's have a think about that. All right, well, we know that we need to set this up a little bit differently. We need to set it up such that when y is 43, okay, remember, I'll just write it here. We know that y was equal to 3x plus 10. That was our equation that we were working on. So now we've got a value of y when y is equal to $43. Okay, so we can substitute that in. We should probably need to write that when y is equal to 43. We did. So 43 is equal to 3x plus 10. We just want to work out the x value. So we'll get x by itself. How do we do that? Well, we'll take 10 from both sides. we'll end up with 33 is equal to 3x. X is still not by itself, so we divide both sides by 3, and we get that x is equal to 11. But what does x is equal to 11 really mean? Well, that means that she must have sold 11 items during that 1 hour to be able to make $43. Last thing I'll show you is a little bit of a graph of what this would look like. We have I'm going to just reveal it all. We have our graph all set up. You'll see that our x-axis is our items sold. That was our independent variable. And our money earned is our dependent variable. We can tell that at 0, which is this one just here, at $0, at $0 or 0 items sold, she makes $10, and then it just goes up in a linear equation, a linear fashion from there. 1 item was 13, 2 items was 16, and so on and so on. And we can see based on here that we were right, that at 5, if she sells 5, she'll make $25. Okay, so that is how you can use the fact that the y is the dependent variable and the x is the independent variable to be able to graph these things. And once you can graph them, you can solve them, read them, all that sort of stuff. Okay.